So, good day everyone. So, my topic is going to tackle about RC feedback oscillator circuit presented by Samantha May Purio. So, let's start. RC oscillator circuit is used a combination of an amplifier and an RC feedback network to produce output oscillations due to the phase shift between stages. And for an RC oscillator to sustain its oscillation indefinitely, sufficient feedback of the correct phase that is positive or in phase. Then next is RC oscillator circuit feedback must be provided along with the voltage gain of the single transistor amplifier being used to inject adequate loop gain into the closed loop circuit. So in order to maintain oscillations, it should be allowed to oscillate continuously at a selected frequency. Then for our next is the RC oscillator diagram or circuit. So in an RC oscillator circuit, the input is shifted 180 degrees through the feedback circuit, returning the signal out of phase and 180 degrees again through an inverting amplifier stage to produce the required positive feedback. So ito, nagbibigay siya sa atin ng 180 degrees plus 180 degrees. So, dalawang 180 degrees na papunta sa input at palabas sa output. Ng 360 degrees ng ating phase shift, which is effectively the same as 0 degrees rather, thereby giving us the required positive feedback, or in other words, the total phase shift of the feedback loop should be 0, or any multiple of 360 degrees to obtain the same effect. So, ang RC oscillator daw natin has three types of RC feedback oscillator. So, first is the Wien bridge oscillator. Second is the phase shift oscillator. And the last is the twin T oscillator. So, starting with the Wien bridge oscillator. A Wien bridge oscillator is a type of electronic oscillator na nagge-generate daw ng sine waves na kaya ring mag-generate siya ng large range ng frequencies. And the large oscillator is based on the bridge circuit originally developed by Max Wien in 1891 for the measurement of impedance. And the large bridge comprises 4 resistors and 2 capacitors. So next is the Wien bridge oscillator diagram, which is the lead-lag circuit. So for our left side, nakikita natin yung circuit natin or denoted as A, and for the left and for the right side is the response curve denoted as letter B. So dito muna tayo sa ating left side, which is the circuit. So based on my observation, the resistance and the capacitance make so the resistance at capacitance ng both resistance 1 and capacitance 1 yun make the lag part of the circuit, and the resistance 2 and capacitor 2 make the leading part naman nung sa circuit. And the working of this lead lag circuit is described here na at less value daw ng frequency, nagli-lead yung circuit operates due to the large value of the reactance of the capacitance number 2. And with the increment of the frequencies and decrement in this frequency, it causes ng output voltage na mag-increase. And at a certain value naman ng frequency, the response of lag circuit dominates and reduces the value of our capacitance or capacitor that causes the output voltage to decrease. Tas here naman sa ating right side, which is the response curve, the resultant curvature of the lead lag circuit can be seen here. Yun na nga, ito, denoted as letter B, na ang ating circuit daw nagde-denote that the output voltage extreme at a frequency known as resonant frequency or F sub R. And dito naman sa location na to, dito sa taas, sa may output voltage, yan yung attenuation daw ng output voltage over input voltage ng ating circuit is 1/3 or 1/3. And as described, the respected expression. So, nagde-describe daw siya ng respected expression kung both resistance natin and both capacitance are equal to each other. So, next is the formula of the Wien-Bridge oscillator, which is the mathematical expression of this resonant frequency is resonant frequency equals to 1 over 2 pi RC. So, for more explanation, the lead lag circuit in the Wien-Bridge oscillator has the resonant frequency, for which phase shift in the circuit is 0 degrees and the attenuation of value is 1 over 3 or 1/3. And a value of less than our resonant frequency, the lead circuit dominated the value or the output lead the input over over the value of resonant frequency lag circuit dominated the output lags behind the input. Then for our second type of RC feedback oscillator circuit is the phase shift oscillator. So, ang phase shift oscillator naman ay is a linear electronic oscillator circuit that produces a sine wave output. Nagpo-produce din siya ng sine wave output, same as the other, which is the Wien bridge. And it consists of an inverting amplifier element such as a transistor or OP amp with its output feedback to its input through a phase shift network consisting of resistors and capacitors in a ladder network. So kung kanina, dun sa ating Wien bridge, nagko-consist siya or nagko-comprise siya ng 4 resistors and 2 capacitors. So dito naman, nagko-consist siya ng resistors and capacitors in a ladder network. Tsaka an amplifier element such as transistor or an OP amp. So next is the phase shift oscillator diagram or circuit. So here, sa nakikita natin, so sabi daw, in every 3 resistor circuit in the feedback loop, it can be offered an extreme phase shifting close to the 90 degrees. So yung tatlong resistor daw na yan ay nag-shift siya malapit sa 90 degrees. And the oscillation exists at a frequency where the net phase shift in the 3 resistor circuit is 180 degrees. And the inversion of the operational amplifier offers the extra 180 degrees to fulfill the need of oscillation of 36 degrees. Then next is the formula of the phase shift oscillator, and the mathematical expression of the resonant frequency is resonant frequency equals to 1 over 2 pi square root of 6 RC. So kung kanina, di ba dun sa Wien bridge natin, kung ang formula na ginamit natin dun ay resonant frequency equals to 1 over 2 pi RC, ang pinagkaiba naman nun dito, may square root of 6 lang siya, which is constant. Kaya wag tayong malilito dun. So last ng ating type of RC feedback oscillator is the twin T oscillator. So the twin T oscillator naman daw ay uses a tuned RC network for the feedback circuit to produce the required sinusoidal output waveform, being two T networks connected together in parallel. They operate in antiphase to each other, creating zero output at the null frequency but a finite output at all other frequencies. So here, nakikita natin ng ating twin T oscillator diagram. So for our left side, nakikita natin the oscillator circuit, and for the right side is the twin T filter frequency response. So starting at the left side, ang ating twin T filter configuration, nagko-comprise siya ng less pass response, habang yung other naman naman nagko-comprise siya ng high pass response. And when it is both parallel filter, it filter that generates a band stop or notch response having a center frequency na nag-equal siya dun sa required na frequency ng oscillation. Na yan, nakikita nga natin dyan sa figure na yan. And the oscillation cannot exist a frequency over a loss of resonant frequency since the negative feedback is passing in the filter. And for our resonant frequency, there is a very less negative feedback in the positive feedback in the voltage divider permits the circuit to get oscillate. Kaya yan. Yan na ganyan siya. And that's all. Thank you so much. And again, I'm Samantha May Purio reporting the topic of RC feedback oscillator circuits.